Go ahead and put it on record. Minimize this thing. Now, my notes say that we got through 35 last time, but I'm pretty sure we got through 36, did we not?
Yeah, we did.
Yeah, we talked about 36.
Yeah, I remember doing that one, yeah.
Whatever makes this denominator 0, that's the key part to know. And then you just have to do a little bit of algebra too.
Oh, before I forget, I took I've taken the PSAT twice now, and I just got back I got back my answers and everything a lot near Christmas, but I just got back the booklet with it, and they actually gave me the booklet with all the questions and the answers to all the questions for the PSAT, the actual one I took that test in.
Yeah, no, that's great. I'm glad you got that.
Is that a good one to go look back at then? Okay.
Yeah, no, that for sure is the way to go. Unless it's the very last SAT you know you're going to take.
Yeah.
You don't need to get that feature. But if you know you're going to take it again, then definitely. That's perfect. You want to know which ones you missed. Okay. All right. So let's pick up on 37. Okay. Go ahead and read. 37 and 38 apply to that paragraph that you see right here. And they're nice enough to give you the formula. That's not one of the formulas given at the beginning of the test when they give you all those formulas. But so they give it to you here.
Okay.
Now, I don't know. Do you know what the answer is?
I might. I just did these, so let me think about it for a sec.
Go ahead before I give you a hint or anything. Let me see if you already know it. I did confirm, incidentally, that get to each section of the SAT, it runs easy to hard.
Okay. Yeah.
So it's not, 1 through 10 is easy and 38 is hard. That's not the way it works. It's the beginning.
Okay.
The beginning, every different section, it goes easy to hard.
Okay. Gotcha.
Which is that's what we were encountering.
Oh, is that why it was we were confused last time about why?
I just wasn't certain about it, and it looked like that was happening. In other words, once we got to the grid section, it appeared that the problems of the grid section were easier than the last few.
Right.
And that's definitely the way it is.
Okay. Okay. So is this is it 0.02?
No. Here's the formula that you were just taught in school.
Because because the one I did in school was we did it was 1 plus R, right? Yeah.
Okay. So what is R?
The percentage.
Tell me what R is in this case.
Yeah, so 0.02.
0.02. So now that makes everything in the percentage be 1.02 to the T. And now this looks a lot like what they've given us right there.
Yeah.
0 is 100. And what's in the parentheses is 1.02. So that's the answer, 1.02.
Yeah.
Put it there. Okay. Now let's look at 38. So let's go back and make sure we've defined the equation that governs this. The amount at any point in time is equal to the initial amount times 1.02 to the t, where t is in years. Okay? Still with me, Ben?
Yep.
Okay, wasn't sure if we were having one of those problems I was expecting.
No, yeah, it looks like it's okay.
Okay, so 38. Again, this has got 9 sentences in it, but it's actually going to be easy now that we have that. In other words, as long as we have that, there's no way 38 is going to be hard.
Mm-hmm.
So let's go through 38. It may take a while. In other words, it may take us 2 or 3 minutes, but we know we're going to get the answer right. All right. So her friend found an account that earns 2.5% compounded annually versus her 2%. Okay. And she made a $100 deposit at the same time Jessica did. After 10 years, how much more money will her friend's account have earned than hers? Round to the nearest cent and ignore the dollar sign. So there's a lot of specifics here, but it is not a hard problem. So let's talk about Jessica.
So, okay, so when it says round your answer to the nearest, oh, okay.
Yeah, when you see stuff like that, don't worry about it until you get to your answer.
Oh, okay.
In other words, that's not part of the problem. That's just part of how to present your answer. Okay. So let's figure the amount that Jessica has. And we don't need to use this formula up here. We can use the one they've given us because the starting amount is 100 in both cases. So this is Jessica. What's T for problem 38?
Time. Yeah, so T's time. So after 10, so T would be 10.
Okay. Now, what is T-Sean's? She puts the same 100 in to her account. What's her inside the parentheses going to be?
1.025.
Same 10 years. And they want the difference. So they want a sub t minus a sub j. That's your answer, rounded to the nearest tenth. So, what kind of calculator do you have, Ben? Sorry.
Yeah, 84.
Okay, good. So you can get an answer on that? Tell me what a sub j is.
Okay. Let's see. Okay.
And make sure you know how to do this. That's why I want you to do it.
Yeah, I just did these in school, so they're pretty easy for me.
Okay, cool. Let me just offer a suggestion. Because okay. you're gonna use your TI-84 to take the test, right?
Yeah, I assume so, yeah.
So rather than inputting it as one thing like that, where if you get a misplaced parentheses, you're dead.
Yeah.
Right? And it doesn't even tell you have a misplaced parentheses. So let's do this part first. And then multiply it by 100. That way you decrease the chance of making a mistake. So take 1.02 and raise it to the 10th power. Do you know how to do that? You use that.
Yeah, my calculator just kind of died on me, so I'm like trying to figure out. I have to like do it with another one now.
Well, you're not going to be able to do this without a calculator. It would take you.
Well, I'm trying to do it with a different calculator.
Okay. Yeah, it would take me probably an hour to raise 1.02 to the 10th power.
Yeah. So should I just not do that then?
If you don't have a calculator, then you're not going to.
Yeah. Because it just died, so I'm like, I don't really have like another one like that to do it on.
Okay. All right. So that's fine. So assuming you can come up with a number, let's say it's 2,000. And we come up with a number. Is a sub t going to be bigger or smaller than a sub j?
It's gonna be bigger.
Okay, so let's make up a number for that. And what they asked for was the difference. How much more money will Tishans have earned? So the difference is the difference in the interest rate. In other words, Tishan must have made $300 more. And excuse me for writing that because you do not grid that in. You do not grid in dollar signs. You just grid in 300.
Okay. Is that what it means when it says round nearest to the nearest cent?
No, I didn't do that. So let me go back and make up some other prices. Let's say that's what Jessica's came out to be, and this is what Tishan's came out to be. Then you would subtract them and you would get 300.1. That's to the nearest tenth. Now, you got to be a little careful about this. You don't want round off error. So you really kind of want to be a master of your calculator here. In other words, let's say that was 0.41 and that was 0.59. Okay? In other words, let's say this is what your calculator gives you. Well, you'd be okay here because the difference is going to round off to 300.2. But honestly, we need your calculator to be working.
Yeah.
Okay, especially for harder problems. We can definitely, this is the last problem on test 1. So we don't need to worry about this one. And we're going to go on to test 2, which is going to start out with easy problems. So we're probably okay for today.
Okay, yeah, I'm just going to charge it.
Your calculator is fully charged, and in fact, have the power cord so you don't have to depend on the charge.
Yes, I will.
Okay. Let's go on to the next test, which is number 2. And these are going to start with, that's interesting. That's very interesting. To me, only. I'm doing presentations for the SAT for this company. And they start with the math.
Oh, really?
Yeah, and they start with the math on day 1. And I figured they started with the math because that was the first one, but it's obviously not. I knew that.
Oh, I guess it's English.
Huh? Yeah, no.
Yeah, I guess, yeah.
Math is at the end. Yeah. It must just be for timing purposes. So here's all those formulas we talked about. And if they expect you to know a formula and it's not on this list, then they're gonna give it to you. just like the last one. Although the last one was a little tricky because we really kind of had to know the annual compounding formula to figure out what was inside the parentheses, what it meant. You know what I mean?
Yeah. So will they also do like compounded continuously too?
Yeah, they do, and they'll generally give you that one when they do it. Let's just review. Okay, so here's definitely have to know that one.
Yeah.
Definitely have to know continuous. Well, not really, because they're going to give it to you. They're liable to give it to you like that. P being a sub 0.
Right.
Okay. And there actually is another one where greater than annual, where it looks kind of like this, but I've never seen one on the test that is greater than annual. Gets a little more complicated, but it looks like that.
Oh yeah, I've done those. Yeah.
Right. You've done those in class, but I don't think you're
Yeah.
ever going to run into one of these. I mean, we just did the toughest one on the whole test, and it was that form right there. And if they do continuous, they give it to you. Now, they kind of gave it to us in the last one because they said it's equal to 100 times x to the t. It's just we had to know what x was. Well, x is that. So you really did kind of have to know this annual one. So that's a good one to memorize for sure.
Okay.
All right. We'll go through these as quickly as possible. Do number 1. We'll see how your speed is. We want to start testing you, or we want to start teaching you about speed. In other words, the first test that we went through, we didn't really pay much attention to it.
Okay. Get some.
You need a calculator, some kind of calculator.
Okay.
Nope, you don't. Sorry, this is the non-calculator portion. I just noticed the top of the page. You don't need a calculator. Don't go. I'm glad your calculator is dead.
Yeah. That'll be fine. Okay.
You can just give me the answer. I'll go on to the next one.
Okay.
Can't, I'll go through the problem. So what's your first step?
So 5x plus 6 is now is a value of 10x plus 3. So I'm just going to solve for x and then plug it into the other equation.
We'll start with step 1. Correct. Tell me how to do it. I want to make sure you know how to do this. If there's one thing you have to know how to do, it's to solve equations, linear equations.
So yeah, so the first step I would do is subtract 6 from each side. And then 5x is equal to 4, so then divide by 5 on each side, and x equals 4/5.
Okay. Now, plugging in, they purposefully gave you a fraction because they want to make sure you know how to do this efficiently. What is that? And how did you do it?
So yeah, that would be 40 over 50?
Nope. It's not the way to do it. The way to do it is to divide top and bottom. First of all, that 10 is a numerator. Understand that. You're not multiplying numerator and denominator by 10.
Oh, okay.
Okay, that 10 is a numerator. So it's the same as this. 10 times 4 all divided by 5. So how would you do that? You wouldn't just multiply the numerator. That's the bad way to do it. What you want to do is simplify. You want to divide top and bottom by 5. If I divide top by 5, I get a 2 there. Bottom by 5, I get a 1 there. Now the answer is 8. And I came up with it without ever dealing with a number greater than 10. Whereas the way you did it, you ended up with 40 divided by 5, which is also equal to 8, but you dealt with big numbers. So, big secret to math is always simplify before you do this stuff. Now, particularly when you cannot use a calculator. You know, if this was a calculator section, well, then I wouldn't even be mentioning any of this. Because you would just do 10 times 4/5 on your calculator and you'd come up with the answer. But the fact that it's a non-calculator section, it's important that you know how to do these efficiently. So, when I do that, I get 2 times 4 is 8, plus 3 is 11. There's my answer right there. Okay.
Okay.
Now, let me suggest one thing. If I change that to a 12, there's an answer that's a shortcut that will cut the time it takes you to do this problem in half. What would the answer be?
12. Sorry, 20.
Yeah. In other words, it's worth recognizing little tips like that. In other words, we can see that that's exactly double that.
Right,
10x
yeah.
plus 12 is double 5x plus 6. Therefore, this has to be double. It has to be 20. So, a lot of times they'll do that, and they'll do it in order to give the person that notices the shortcut a little bit of an advantage. They want to see that. They want to give you an advantage if you notice that shortcut, as opposed to the person that has to go through the difficulty of solving both equations, which takes quite it takes quite a bit of time longer. So, I'm at number 2.
This would probably be easiest to do elimination.
Well, you got a bunch of choices here. First of all, if you're going to do it algebraically, which is fine, yes, I would definitely choose elimination. Okay?
Okay.
So let's do that. I like that idea. So tell me how to solve that with elimination.
Okay. So
equation 1, call that equation 2.
Okay. So yeah, so first I would just kind of look at it, and then so if I want to eliminate one of the variables, then I can do 3, or no, let's do, so multiply equation 1 by 2.
I like that. So what's equation 1 become?
2x plus 2y equals 0.
We're going to add that to equation 2. That was why you chose y as the variable, because you didn't have to mess with negative signs or anything.
Yeah,
What
it just easily cancels out. So then you get 5x is equal to 0.
Nope, you got to add those also.
10? Oh, sorry.
Okay,
10.
so I'm glad you said that, because you have to add every part. You got to add those, You got to add those, and you got to add those.
Oh yeah, no, I know that. I didn't see the 10. I just saw 0 and 1 with it.
So x equals 2. What's the next step?
So now that I know that x is equal to 2, I can just plug that. I'd probably plug it in the first equation 1 because it just makes it easier. So
stop for one moment. Look at the answers before you do all of that.
Okay.
What's the answer?
B.
See, you didn't need to do that second step.
Yeah.
The second step wasn't hard, because once you plugged in 2 for there, you would have realized the y had to be minus 2 to be equal to 0. And you'd have gotten to b. But sometimes you don't have to do that. And in fact, more than sometimes. I would say most of the time, when they give you 2 equations and 2 unknowns, if you do it properly, in other words, if you did it the way you did it, and we did have some choices, we could have solved for y first. Well, notice that a lot of the y's have -2. So if I'd have solved for y first, I'd have had to go ahead and solve for x to come up with the answer. But by solving for x first, there was only one x answer of +2. So I'm done by solving for x first. Now you say, well, you could have just as easily solved for y by multiplying the equation 1 by -3. But in the interest of not making mistakes, you're always better off dealing with positive numbers, not negative numbers. So I like the fact that you chose to eliminate y because you could multiply the top by a positive number and a smaller number. 2 is smaller than 3. So you chose the most efficient way to go, and they rewarded you with it by showing you only one answer that had 2 as the x result. And you'd be amazed at how often they do that on this test. If you do the problem in the way you're supposed to do it, they will give you a little bit of an edge. And you'll save 15 seconds or 20 seconds or whatever it says.
Okay.
Okay? All right. How about number 3? Again, another rule of thumb is just because it's got this many lines in it, probably means that it's an easy problem.
Mm-hmm.
Seriously, I'm beginning, I never really had come to that conclusion before, but I'm beginning to. The longer the number of lines, the easier the problem is.
Okay. Makes sense.
Not that this would be ever number 1, but it certainly is a problem that I think you can probably do.
Yeah.
It's not even a problem to do, it's a problem to understand.
Yeah.
But in reality, if you think about real life, you can figure this out.
That's true. So wouldn't it be in that case A?
Yes. Yes. And there's a lot of common sense to that. Okay, first of all, that sounds like a reasonable answer, that you would be paying a landscaper $12 per hour. Okay, this minimum of 12 landscapers will work on each job? No, that doesn't make sense. The price of every job increases by $12 per hour. Well, if you think about that, that doesn't make sense, because what if you have a giant job? In other words, if you have a giant job that requires 100 landscapers, well, you can't charge just $12 for every hour. You got to charge $12 per every landscaper. So we can kind of eliminate that. Each landscaper works 12 hours a day. No, I don't think so. So you can almost figure this one out just by eliminating bad answers. Answers that don't really make any sense.
Okay.
I'm not sure how you did it, but that's okay. We'll go.
Basically, yeah, basically what you did.
All right. Now these are probably medium, maybe. I don't know. We're only on number 4, and we're still in the non-calculator part.
Okay.
What if your life depended on it? How would you answer this problem? Let's say they gave you an hour, and they said you live or die, depending on whether you get the answer to this correct. What would you do? How would you do the problem?
Well, I think first I would kind of look over in the equation and see, like, define like variables.
No. You're going to die if you don't get this right.
Okay.
Seriously. You got an hour to live or die. What are you going to do? You're going to do each of these things. You're going to do that. By doing it, I mean you're going to square that term and see what you get.
Okay.
If it's the same thing, that's the answer. Okay? Then you're going to take that to the 4th power, which means you're going to square it and then multiply it again and then multiply it again. Remember, you got an hour. Okay? And then you're going to try that. Well, that's just squaring that. And then you're going to take that to the 4th. Well, knowing this is problem 4, is it likely that we have to take anything to the 4th power, a binomial?
No.
No. And that quite simply really is the only way to answer this problem, is to do each of these. In other words, you're back solving. Back solving is the only way to do this. And I'm not going to rule these out, but I'm going to say that they don't think you're going to take that to the 4th power. That would take about 5 minutes.
Yeah.
So we're not going to do these. So let's just rule those out for the moment. Now we're between A and C. What's the first term if you square A?
If I square A, is 9A to the 4th.
What's the first term if you square C?
4B to the 4th.
No. First term.
Okay. 81A to the 4th.
Is that the correct answer?
No. So it's A.
Well, we don't know it's A for sure. But if we're running short of time, we pick A. Okay? And in fact, the math isn't that hard. Let's do it over here. And they give you a break here by making the answer A. That's not accidental. They don't want you spending 10 minutes doing this problem. Okay. Oops, excuse me. I didn't mean to write it like that. I meant to write it like this. In other words, you can use a little bit of logic here. This is going to take a little bit of time to do, to verify that it's A.
Mm-hmm.
If I have a minute, I'll do it. If I have 10 seconds, I'll just answer A and go with it. Because I just can't imagine that it could be B. Imagine that if B or D were the correct answer, how much work I would have to do.
Mm-hmm.
Plus D, you got to take 9A to the fourth power. You're going to have much more than 81. So I can definitely eliminate D. This one, when you square it, you get 9. And then when you cube it, you do get 81. So I can actually eliminate both of those without too much math. And I have eliminated that one. So yes, I can answer A now and bet my life on it.
Okay.
Without actually doing it.
Okay.
Without actually foiling it. If I do foil it, I will see that that's what I get. But this is one of those cases where it's relatively easy to eliminate 3 answers. And whenever you come across a problem where you can eliminate 3 answers, do not waste the time checking the 4th answer. You're done. Go on. Answer that 4th answer and go on. Just be very sure with your math. In other words, when you're eliminating some of these answers, be very certain of yourself.
Okay.
It can't be maybes. In other words, the first time through that problem, I thought that B and D, there's no way that that could be an answer because they're not going to force you to do that multiplication. That would take 20 minutes to do that multiplication. So that's not going to be an answer. So it's a reasonable assumption to eliminate B and D from the answer choices.
Right. Okay.
That is frequently the secret to taking this test, is to be able to eliminate answers, and then you're choosing from the rest, or guessing from the rest. Okay, let's look at 5. Again, we see the tougher problems are shorter in length. This is going to be an easy problem down there. Compared to this problem we're looking at, compared to this, that's the easier problem, and I haven't even looked at them. This is my first go-around on test 2 with anybody.
Mm-hmm. Okay.
So I'm just saying, we'll see if I'm right or not.
Okay.
Let's look at 5.
Okay, so would this be a good one to just back solve?
Yeah, I love back solving here. Where are you going to start?
Okay, well, I know that x is equal to 7, so I can automatically plug that in. And I know that x is greater than 0, which doesn't really help me that much considering the choices are all greater than 0.
Which answer are you going to start with? In other words, if you're going to back solve, are you going to start with A?
No.
Which one?
Always
start with either B or C.
B or C? Okay.
And what that will guarantee is that you have to do at most 2 calculations. If you start with A, you might have to do 3. In other words, you do A, B, and C, and if none of those worked, you know the answer would be D. So you might have to do 3, but if you start with B or C, you will never have to do more than 2.
Okay.
Okay? So start with B. Tell me what to do next.
All right, so then it'd be square root of 2 times 3 squared plus 17, and then outside of that squared one, minus 7 equals 0.
Okay, now let's see if that's true. If that's true, then we're done. What do we got? We got the square root of 18 plus 17. Square root of 35 minus 7. Is that equal to 0? Is it?
No.
Figure out what the square root of 35 is.
Okay.
I have your calculator. It's between. It's
I can.
6, right?
Yeah, I can figure out what it's between.
Okay, so it's less than 6. We'll call it 5.9.
Yeah.
Minus 7. Does our correct answer have to be bigger or smaller than 3?
It has to be bigger than 3.
Okay, that eliminates that and it eliminates that.
Yeah.
So now, regardless of whether you try C or D next, you'll have the answer.
Okay.
Pick one. Let's try it.
I'll do 4.
Okay. The best one to pick because the answers are smaller. The numbers are smaller. So that's 16. And then that is 32 plus 17 is 49. Bingo.
Yep, that'd be it.
And if that didn't work, we're done. We answer D and we go on. And that's why you start with B or C as answers.
Okay.
Because you never have to do more than 2 calculations. Now, had we been lucky enough to start with C, we'd have gotten it on the first one. But that's pretty random. But you can ensure that you never have to do more than 2 calculations by starting with B or C.
Okay.
And yeah, when you take the ACT test, there's an E. In other words, the ACT test has 5 multiple choice answers.
Okay.
Which one should you start with?
C.
No. That's what all the books say, and they're all wrong. Trust me.
B?
B or D.
Okay.
The second lowest or the second highest. Absolutely, I'm 100% convinced. Even though all the books say C.
Why do they say that?
Even my company that I'm doing these presentations for tell me C. C is not correct.
Why do they tell you that?
Well, I don't know. To be honest, I don't know, but I can prove it to you real simple. If you begin with C, you will get the correct answer on the first attempt 20% of the time, correct?
Mm-hmm.
And then you'll be able to know whether to try B or D next, so you'll get it 100% of the time on the second answer. That's if you start with C. Let's say you start with B. What percentage of the time do you get the correct answer on the first try?
Like,
it's not 20, it's 40.
Yeah, it's double.
Because whenever A or B is the correct answer, you discover it when you begin with B. And if A or B is not the correct answer, then you're going to try D next. You're going to get it 100% of the time. So there's the comparison. This is when you start with B or D. This is when you start with C. Well, this is like twice as good.
Yeah, literally.
Literally, yeah. Although, I don't know if it's necessarily twice. It's better, but
significantly, yeah.
Yeah, significantly. Yeah. In other words, it's not necessarily twice as good because you don't get the right answer on the first time very often. In this
Right.
case, you get it 1/5 of the time. In this case, you get it 2/5 of the time. But what is amazing to me is that every textbook I have seen in America tells you to start with C.
It's interesting.
Well, it just shows you that authority is not always correct. That's a probability problem, actually. So it's a little disappointing that they have the wrong answer, and it's just a probability problem, which they're actually supposed to test on this test.
Yeah.
You're supposed to know probability on this thing. So, all right. Again, another question with parallel lines and transversals.
Mm-hmm.
We can tell the moment we see this picture, there's the parallel. Excuse me, hold on. In fact, I messed up there. I got to go back now. Okay. Obviously, there's the parallel line.
Mm-hmm.
And you have two transversals. You have that transversal, and you have that transversal. And that's a very common technique that both SAT and ACT do. They're not just going to give you two parallel lines and one transversal and say, which angle is angle 1 equal to? Is it equal to angle 3 or angle 4? That's too simple. That might be a question 1, but that's never going to come as a question 6.
Okay.
However, you have to know that principle. You have to know that it's equal to angle 4.
Yeah.
Because they're both obtuse. Because all you have is an obtuse and an acute. Now, let's see. This looks a little different. Let's see if it is. It's only question 6, so it shouldn't be that hard. What is the value of P?
I could make an educated guess just by looking at this thing.
What would you say?
I would say, just by looking at it, 8. I'd say C or D.
So you're graphically looking at it.
Yeah, because I also, when I'm looking at the angles, then I'm kind of graphically looking at, like, on,
I got no problem with that solution at all.
yeah.
I like it also. However, I'm not sure if it's 8 or 10.
Yeah.
I know it's not 4, right? And cross that.
Yeah.
Because clearly this distance from here to here is greater than the distance from there to there.
And I assume it's not 5 either, because looking on the other side of it, if that's -5, there's no way that's...
I don't know. What's the relationship between that number and that number? 2 to 1, right?
Yeah. But that looking at that one makes sense. Because are you saying these, because I don't remember, did you say these are drawn to scale?
Well, if it does not say not drawn to scale, yes, it is drawn to scale.
Okay, it's drawn to scale. Okay, well, looking at 2 and 4, then yeah, I would agree with them. That can make sense.
Well,
but
that would be my guess based strictly on that. And in other words, the math here is actually pretty hard. I'm not quite sure how to do the math, to be honest with you.
If I were to, honestly, I would probably say C, if I'm making an educated guess on that.
Yeah, but the problem is that it's not just a coincidence that 4 is 2 times 2.
Right.
And that would lead me to believe, in fact, 4 is -2 times 2.
Mm-hmm.
Well, that would lead me to believe that P is -2 times that x coordinate, which would be +10.
And yeah.
Now, I guess we could draw a parallelogram. Whoops, no, we can't. Trying to figure out how I would actually do this mathematically. I'm relatively certain 10 is the right answer.
Yeah.
If you had a little piece of paper, measure that distance. You don't need a ruler. Just take the corner of your paper and measure it. And I'll bet you anything this is twice that. And you could test it by taking that measurement, measuring it to there. That's the same measurement. Going all the way to there, that's the same measurement. So you can actually answer this question by measuring, using nothing but a piece of paper and a pencil.
Okay.
Okay.
Is that maybe kind of the direction they're trying to lead you in?
I'm sorry, what?
Is that kind of maybe the direction they're trying to lead you in with this problem on how to solve it?
I'm not sure. I'm trying to figure out how I would actually figure this out. In other words, we know that angle is equal to that angle.
Right.
And we know that that angle is equal to this angle. The problem is that I don't know that that makes the problem easier.
I don't think that really helps us any, does it?
No, it doesn't. If we look at that triangle right there, we're looking at a 2, 5. Well, that doesn't help.
Wait a minute. Okay. So if you have those two triangles there, can't you just...
They're similar triangles. They are definitely similar triangles. This triangle here has to be similar to this triangle here because they're parallel lines. In other words, it has the same angle there. It has the same angle there. If you have two same angles, you have three same angles. Now, the 4 and the 2 definitely means that this side has to be twice that side.
Twice 10, yeah.
So that's the way to do the problem, is to perceive it as similar triangles. And this is a good one. I like this one. They don't tell you they're similar, but the parallel lines in the x and y axis make them similar. And once you know they're similar, then the p being equal to 10 pops out at you.
Yeah, it does. Yeah.
You hardly need to do the math. It just, you know it's got to be 10. But, like I said, there's two very good ways to do that. The quickest way probably is by measuring with a piece of paper. Just take the corner of a piece of paper and stick it up there and measure it and see if that measurement to P is twice that.
Yeah, okay.
And that would take about 10 seconds to do, and you would have your answer. Yeah, on both the ACT and the SAT, if you see a figure, you can assume that it's drawn to scale unless they say otherwise. And if they say otherwise, then you have to do the problem mathematically. But if they don't say not drawn to scale, you can assume that it is. And you can solve this thing in 15 seconds. You know?
Yeah, then it becomes super easy, yeah.
See if we can do one more here. We got 5 minutes. Let's see if we can do number 7. Real quickly, how would you be inclined to do this? Algebraically, back solving, picking numbers? Which one? What would be your first inclination?
Picking numbers?
No, picking numbers works fine when you got variables in the question, but you got to have variables in the answer. So that's probably not going to work really well.
Okay.
Back solving.
Really?
No. I'm about.
Okay.
Very good. Very good. That's not going to work very well because of the nature of the question. They're not asking about A or B. They're asking about the difference.
Yeah.
That's not a type question that lends itself well to back solving. So,
Yeah.
no, I'm not going to do back solving. So let's algebraically tackle that right there. What is
Okay.
that equal to? Using the laws of exponents. What do you do when you're dividing same base, different exponents?
Can you? I don't really remember actually.
All right, well, we need to go over that real quick. X to the A times X to the B. Here's the same base, different exponents. It's equal to X to the A plus B.
Oh, okay. Yeah. Okay.
Okay, so what do you do when you're dividing? What do you do to the exponent? Do what?
Subtracting.
Okay, so what I've circled is equal to this. And they're telling us that's equal to X to the 16th. Now what can I say? I got this to one exponent equals the same thing to a different exponent. What has to be true?
Oh, x has to be equal to each other.
No, these have to be equal.
Oh, yeah. Okay, yeah. So then you can just solve it out.
I can say this. A squared minus B squared has to be equal to 16.
Okay. Oh, because yeah, same base.
Well, this
Right.
has many steps to it. This is definitely one of the harder problems because it covers a couple of different algebra principles. Now what? In other words, I get to this step. They want to know what A minus B is.
Can you from here? Can you pick numbers?
How do you factor that? No, you can't.
Oh.
Got to know this step right here.
Okay.
How do you factor difference of perfect squares? That's what we're looking at here. We're looking at the difference of perfect squares. A squared is a perfect square, B squared is a perfect square. And they're being subtracted. So they factor into A minus B times what?
Oh, a plus b.
Yeah. That's equal to 16. And that's why they told you what A plus B was.
Oh, okay.
So now I've got 2 times A minus B is equal to 16. What's A minus B equal to?
8.
Yeah. So this is a great problem. It's a difficult problem, but it encompasses all kinds of stuff in it. You have to know how to handle exponents. In other words, you have to know your exponent rules, and that's absolute. You do. They're not going to give you those. You have to know those 3 exponent rules. Okay. Then you have to know that you can equate the exponents. If I've got x to the alpha equals x to the beta, then alpha has to equal beta, no matter how complicated or what it is.
And that's because they have the same bases.
Yes. If you have the same basis to different exponents, then the exponents have to be the same.
Right.
Then you have to realize you're looking at difference of perfect squares, and you have to know how to factor that. Third major algebraic principle in this problem is how to factor difference of perfect squares. Once you get to this step, you're pretty much done.
Yeah.
Look back and see the problem and see that they tell you A plus B equals 2. Now you can solve for A minus B.
Okay.
But That is the way to do that problem. And that's a great problem, but it's also a hard problem. But you should be beginning to see that the hard problems aren't hard. They're just a combination of easy problems. In other words, if I gave you easy problems at each step of the way here, if I told you what 2 to the 4th divided by 2 to the 3rd was, you'd probably know that that's 2.
Yeah.
And then if I gave you the second problem, you'd be able to answer it. If I gave you the third problem, you'd be able to answer it. The only reason it's hard is because all 3 principles are combined in one problem.
Okay, yeah, because I remember, because like, is that kind of like the same thing as like, so I can kind of relate it to like using, like when you're using logarithms and you're expanding and then condensing those, and is that kind of like the same idea here?
Kinda, yeah. The logarithms, you have to know your log rules, and it's generally just one step. But
Right.
this is
Okay.
3 distinct different algebra principles. In other words, it's the rules of exponents, it's factoring, difference of perfect squares, and then it's how do you solve a simple algebraic equation. So there are 3 completely different algebra principles in this problem. And I love that. And I don't know how many of these types of problems you're going to find on the test, but they're great for practice tests because you have to go through and learn all 3 algebra principles to get the answer.
Okay. Yeah. Yeah. It's that definitely makes sense. Like once we start doing it, I definitely start to catch on much quicker.
Kind
I
of
just
go step by step. And the
yeah,
hard problem, it doesn't necessarily mean the thing's going to be hard. It just means they're going to be 5 steps instead of 2.
Right. It's just kind of like recognizing, like looking at it and then recognizing that's what you have to do.
Yes.
That repetition and getting down that.
Yes.
Okay.
All right, Ben. I will let you go. You have a good rest of your weekend and good week, and I'll talk to you next Saturday.
Great. Thanks. You too. Appreciate it.